Welcome to another exciting episode of Dr. Carminati's channel, where we explore the transformative intersections of AI, cybersecurity, and quantum computing. Today we dive into a topic that is growing in importance as technology continues to advance: anti-drone technologies and procedures. If you're intrigued by the world of drones and their countermeasures, you've come to the right place. Please feel free to share your thoughts in the comments section below, and don't forget to like and subscribe to stay updated on more fascinating content. Let's get started. Drones, or unmanned aerial vehicles, UAVs, have revolutionized industries ranging from delivery services to photography and even public safety. Yet with these advancements come challenges, and that's where anti-drone technologies step in. First, we need to establish what we mean by anti-drone measures. These are tools, strategies, and procedures designed to detect, identify, and mitigate or neutralize the potential threats posed by drones. Whether it's protecting critical infrastructure, safeguarding public events, or ensuring privacy, these technologies play an essential role in modern security systems. Anti-drone technologies can be categorized into three main operating stages: detection, identification, and mitigation. Let's break down each one. Detection technologies. The first step in any anti-drone strategy is to detect the presence of an unauthorized drone. Detection systems utilize a variety of tools, including radar systems, radio frequency, RF analyzers, acoustic sensors, and even optical systems. Radar is effective for wide area surveillance, identifying objects in the sky by bouncing signals off them. RF analyzers focus on detecting the communication signals between drones and their operators, which is a particularly efficient method when the drone operates in controlled airspaces. Acoustic sensors, as the name implies, rely on sound. These systems are programmed to recognize the distinct noise signatures of drone rotors. Finally, optical systems, which often include cameras with high magnification and infrared capabilities, allow for visual confirmation and tracking. Identification technologies. Once a drone is detected, the next step is identifying whether it poses a threat. Identification often involves combining data from detection systems and applying AI-powered algorithms to classify the drone model, assess its capabilities, and determine its intent. For instance, distinguishing between a delivery drone and one equipped with potential payloads for surveillance or harm is crucial. Advanced software can also map out the flight path and even identify the location of the operator in some cases. Mitigation technologies. Here's where things get even more fascinating. Mitigation methods aim to neutralize or deter unauthorized drones. Options include jamming systems, which disrupt the communication link between the drone and its operator. Other tools include GPS spoofers, which manipulate the drone's navigation system, effectively causing it to lose its way. More advanced options include drone nets deployed by interceptor drones, electromagnetic pulse, EMP systems that turn off drones electronically, and even laser systems for high-precision destruction. Non-lethal options, such as signal returning systems, redirect drones to safe zones without causing damage. Implementing anti-drone technologies requires a strategic approach that considers the specific use case, environment, and budget. For example, airports and power plants might invest in large-scale systems that integrate radar, RF analyzers, and visual identification tools. These systems are often operated through centralized control rooms, where trained professionals monitor and respond to potential threats in real time. Public event organizers might deploy portable systems, which can be temporarily set up to safeguard concerts, parades, or sports venues. These compact solutions often rely on a combination of RF analyzers and visual detection paired with handheld jamming devices for mitigation. For critical military operations, advanced counter-UAV systems like autonomous interceptor drones or EMP-based solutions might be deployed. These are designed to operate in high-stakes environments where precision and speed are essential. Now, this is an interesting question. While large-scale anti-drone systems are typically reserved for governments, corporations, or law enforcement, there are solutions available to the everyday individual. Personal drone detection devices have become increasingly accessible. These tools, often small enough to fit in a backpack, alert users when drones enter a defined perimeter. They're popular among property owners and privacy-conscious individuals. Additionally, some home security systems now include drone detection capabilities, integrating acoustic and optical sensors to identify nearby UAV activity. While these systems may not offer the same mitigation capabilities as professional-grade systems, they provide an essential first line of awareness. For mitigation, things become more limited. Due to regulatory restrictions, devices like jammers or GPS spoofers are often restricted to law enforcement or certified professionals. However, some innovative solutions, like drone net launchers or interceptor drones, are starting to gain traction in the consumer market. These tools allow individuals to neutralize unwanted drones without violating airspace laws. As drones become ubiquitous, the need for countermeasures grows. Consider the potential threats. Drones can be used for illegal surveillance, smuggling, or even acts of terrorism. They can disrupt air traffic or invade personal privacy. Anti-drone technologies are critical in mitigating these risks, ensuring that drones are used safely and responsibly. Moreover, the rise of autonomous drones, those not reliant on a direct communication link with an operator, adds a layer of complexity to the equation. These drones require advanced AI-driven countermeasures capable of predicting and responding to their behavior in real time. It's also important to acknowledge the ethical and legal implications surrounding anti-drone technologies. In many regions, jamming signals or intercepting drones may require specific permissions. There's also the question of proportionality. What measures are appropriate in response to different types of threats? Understanding these legal frameworks is crucial for everyday users. Using mitigation tools irresponsibly or without authorization could result in legal penalties. Public awareness and education play a key role in ensuring that these technologies are deployed ethically and effectively. The future of anti-drone systems looks incredibly promising. Advances in AI and machine learning are driving the development of more sophisticated detection and identification tools capable of operating in increasingly complex environments. Hybrid systems, which combine multiple detection and mitigation methods, are becoming the norm, ensuring comprehensive protection against diverse threats. Furthermore, the integration of anti-drone technologies into broader security ecosystems, such as smart cities or interconnected defense networks, is an exciting prospect. This will allow for seamless collaboration between different systems and stakeholders, enhancing overall effectiveness. The field of anti-drone technologies is as dynamic as it is vital. As drones continue to evolve, so too must our strategies for managing their risks and maximizing their benefits. Whether you're a policymaker, a security professional, or simply someone curious about this cutting-edge field, understanding these technologies is a critical step toward staying informed and prepared. Thank you for joining me today to explore this fascinating topic. If you found this video insightful, please share your thoughts in the comments below. I'd love to hear your opinions and questions about anti-drone technologies. Don't forget to like this video and subscribe to Dr. Carminati's channel for more in-depth explorations of AI, cybersecurity, and quantum computing. See you next time.